And hi and welcome to this last video on the Bernoulli distribution, and we're going to talk about determining sample sizes. So in this video I'm just going to do example 7 and talk about what this kind of thing means. It does cover exercise 15C, and it just takes these questions a little bit further and how you might solve them. So in example 7, the probability of hitting a target with an arrow is 0.05, so it's a bow and arrow or archery thing. How many shots must you take to be 95% certain of hitting? Now, it's not overly specific, but it looks like hitting at least once. So I've got X is equal to the number of hits of the target. It says how many shots, which means I don't know N. So let's let N just equal some number K, but I know the probability of success is 0.05. So that means I want to know when is the probability that X is greater than or equal to 1 going to be greater than 0.95 for the first time. For what N value? For what N? Now, you could do this, and as you've seen in previous videos, you could use a table function in your calculator quite nicely, or you could just use a bit of trial and error. So for example, on the table function, if I exit out of here, I could set up a new binomial distribution, not by doing that. Option, stat, distribution, binomial CD, and in this case I want to look at changing the X, so I want my lower bound to be 1, my upper bound to be X, my number of successes X, and my probability of success 0.05. So this is about going from 1 to X. I just want to hit at least once where there's X events, and then the probability of success is 0.05. And then I'm going to set my table to go from 0 doesn't make sense now, so I've got to have at least one event. But I might go up to say 30 just to make sure it encompasses. Steps of 1 because it's discrete. Let's have a look at the table. So this is telling me this is Y4. So I've got a 0.05% chance of hitting once out of 1. Then it goes up to there. Now I want this to go up to 0.95. So as I scroll down, I'm looking for that 0.95, the magical number. And I'm worried I might not actually make it. And I haven't made it, so easy fix. I go back, I set my table, and I leave it as 1, set, but I change this to 50. Let's see if I hit it this time. If you make it too large, it takes too long to do the calculations. And just while I'm here, I might just show you this very quickly. If I go up to the Y1, 2, and 3, I can deselect by pressing F1. You see that the equal sign is now not filled in, and that means that when I draw the table, I only get one list of data, which is a lot nicer. Now, I probably could have cut out the previous 30 because I know I don't get there in time. Let's see, I'm almost there. Oh, still not far enough. Crazy. So let's just set this. Let's start at 50 and let's go to 100. It's got to work. Let's have a look at the table now. 50, I want to get to 95, and there it is. So 58 is not enough, 59 is enough. So you can use the table like that, and I say N equals 59 from the table function on calculator. But the question like this is another way as well. I want the probability of X being greater than or equal to 1 to be greater than 0.95, and that means that I want 1 minus the probability that X equals 0 to be greater than 0.95, and that means that I want the probability that X, I'm having trouble writing here, equals 0 to be greater than negative 0.5. I multiply by negative 1, which actually also swaps the inequality around. I get the probability that X is equal to 0. I want that to be less than 0.05, and that makes sense. I'm looking for when that happens. And the probability that X is equal to 0 is XC0 times by Q to the power of X. And I've written X. There we go there. Well, I'm saying, actually, I've called it K, haven't I? So let's go K and K there. I want that to be 0.05. KC0 is just 1. So I basically just get 0.95 to the power of K is less than 0.05. and I can do that. This is now a log question, so I get 0.95 equals, to the power of k equals 0.05 is going to be that crunch point, and therefore k will be equal to log base 0.95 of 0.05. 0.95 to the power of what equals 0.05, and I can do that in my calculator. Menu, go back up to, so I've gone too far there, run matrix, and in my math menu here I've got log AB, log 0.95, 0.05, and I get 58.404, 58.404, which means that 58 shots will be not quite there, so we get k has to equal 59. That's the first time that I can be 95% certain that I've hit at least once. So have a play around with some of those harder questions in 15C, and obviously ask questions as you need to. All the best.